Jolly growing hierarchy. Explained. Okay. Pre-Jolly growing hierarchy. We have n curly brackets n. This is n up arrow repeated n times n. A curly bracket 1 curly bracket b is equal to a curly bracket a plus b curly bracket b. A curly bracket 2 curly bracket b is equal to a curly bracket a plus b curly bracket b curly bracket b. We continue this. A triple curly bracket 1 triple curly bracket b is equal to a double curly bracket a plus b double curly bracket b. We could denote multi-brackets notations like this. A curly bracket c curly bracket 5 curly brackets b is equal to a quintuple curly bracket c quintuple curly brackets b. A circle c b is equal to a curly bracket c amounts of curly brackets b. We can make large notations like this, such as 10 circle 10 is equal to that. We can stack circle notations like this. Circle 10 cannot exist because circle n by itself isn't a number. Jolly growing hierarchy, side notation and lower. J0n is equal to n circle n. J1n is equal to J0n, where J is repeated n times. You get the gist. J2n repeats J1n times, so on and so forth. J psi 1n is equal to Jnn. So psi 1 is treated as n. Psi 2 equals psi 1 tetrated to psi 1. Psi 3 is equal to psi 2 tetrated by psi 2. Psi 2. Psi 1 10 is the limit of psi n. Psi 1 is equal to psi 10 tetrated by psi 10, and psi 20 is the limit of psi 1n. Psi 100 is the limit of psi nn. We can make large notations like this. J psi 10 9 8 7 6 5 4 3 2 1 10, but we will never overtake large FGH notations if we just use this fine notation, I think. JGH psi limit ordinal and higher. PLO is the limit of the psi notation, which marks a new era. Phi 1 equals PLO, and PLO tetrated to PLO equals psi 2. Phi 2. Phi 2 tetrated by phi 2 is equal to phi 3. Phi 10 is the limit of phi n. You got the gist. Sigma 1 n is equal to psi n. Sigma 2n is equal to phi n. Sigma 10 n is the limit of sigma nn. Sigma n repeating is what we could represent with this. Large sigma ordinal, or LSO, is the limit of psi n repeating. LSO is the non-JGH extended limit. Extension 1. Extension 1 new symbols. Ordinal later. F definition goes here, and F's custom definition is whatever could be described with nth order set theory language plus JGH ordinal systems. F could be at any growth. The reason it is excluded to extension 1 is that if added to base JGH, then JGH would be whatever the current describer says F is. F also doesn't have to make a finite value. HUN, F definition goes here K, where if N was 1, then it would be the same as base F. But if we use 2, then it would look like, if this was 2, then it would look like F repeated N times N, because, well, F is repeated N times. For simplicity purposes, let's say that F is already defined. When using F in a real function, you have to mention what definition F is using somewhere when using HU. Extension 2, probably the final canon JGH definition for now. Bottom left, top right, definition languages allowed N is F except with one more thing. The definition has to be defined using language L limitations. If a language is an extension of another language, then the not extended language is also counted as the language is allowed. Plus JGH ordinal systems, obviously. We could write this like this. Symbol definition, first order set theory, and MK allowed. And since MK is an extension of MK, then MK is allowed. Also included in the allowed languages. So language L can bring in L, and if L is an extension of L minus, then L can bring in L minus. But L plus cannot bring L plus plus, because L plus plus is an extension of L plus and not the other way around. HU is also allowed to use this like this. HUK, this definition language is allowed, and since all HU does is repeat the function inside a certain amount of times, determined by K. So yeah guys, 5 subscribers and I'll make an extension that beats F5N. Crazy!